Let's take question 1. Question 1 said, a plastic rod is rubbed against a wood sheet, thereby acquiring a charge of minus 0.6 microcoulomb. Full stop here. How many electrons are transferred from the wood shred to the plastic? We are given options here, so let's solve the question to know the right option. Now to solve this here, solution first. To solve this or to calculate this, we have to look into quantized charge. What is a quantized charge? The formula for quantized charge is given as this, that is in Q is equal to plus or minus NE, where this Q here represents quantized charge and the N represents the number of electron, while this represents the E charge, and this E charge can either be electron or proton. Please take note. So the plus or minus depends if the E is either an electron or proton. So if the E is an electron, the sign that will be taken here is minus. But if the E is a proton, the sign that will be taken here is plus. Please take note. So let's add the available parameters given to us here. From the question here, Q is given to us as, that is Q is given to us as minus 0.6 microcoulomb. Of course, this micro here is a prefix and it has a value which is times 10 raised to power minus 6. So when you replace this, I will have this to be minus 0.6 times 10 raised to power minus 6 coulombs. So the next given to us here is the said electron, and there's a value for electron E is given to us as minus 1.6 times 10 raised to power minus 19 coulombs. Please take note. And we are asked to find the number of electron, which is N. So let's replace the values in this formula here, that is Q equal to plus or minus NE. Q is minus 0.6 times 10 raised to power minus 6 is equal to the mentioned electron here. That means I will take minus sign. This will be minus N times 1.6 times 10 raised to power minus 19. Okay, our intention here is to make N the subject of formula. Making N the subject here, N will be equal to plus minus 0.6 times 10 raised to power minus 6 divide by minus 1.6 times 10 raised to power minus 19. Of course, this minus will cancel this minus. Okay. When you punch your calculator, that is this 0.6 divided by 1.6. I will have this to be N to be equal to plus 0.375 times 10. Of course, from the law of indices, this is 10 and this is 10. We take only one. We operate on the powers. Okay, operating on the powers here, we have this to be minus 6. Taking any power from denominator to numerator, the sign of the power will change. The same thing here, whenever we are taking any power from numerator to denominator, the sign will change. So taking minus 19 from denominator to numerator, I will have this to be plus 19. Our total answer here will be equal to plus 0.375 375 times 10 raised to the power of minus 6 plus 19 will give us 13. So expressing everything here in standard form, I will have this to be 3.75 times 10 raised to the power of minus 1 times 10 raised to the power of 13. Okay, the 10 raised to the power minus 1 is gotten from here, making this to be in standard form. Please take note. So minus 1 plus 13 will give us 12. So our last answer here will be equal to class 3.75 times 10 raised to the power of 12 in electron. Okay, so this is the number of electrons in the charge. So the option here is D. Okay, so let's solve the next question here. That is question 2 under repeated questions in physics 112. Question 2 said 2-point charges 2-point charges attract each other with a force F. Full stop here. If the charges on both particles are doubled with no change in separation, the force between them will be, the options are A, F, B, 4F, C, 2F, D, 8F. So let's solve this question here to know the right option here, solution first. Okay, they said 2-point charges, all right, attracts. So we have a point charge can either be positive or negative. So when they attract, means that one will stand as positive charge while the other will stand as negative charge. So we have something like this. This is a charge. We can take this as plus Q, and this is a charge. We can take this as minus calculator Q to differentiate this. So they are separated with a distance here. The distance here, we can call the distance here D. All right. Now there's something we have to understand here, that when we have two charges and we are asked to find the force between the two charges, we apply Coulomb's law. Please take note of that. Note that to calculate, let's take a note here. Note that to calculate the force between two charges, we apply Coulomb's law. Okay. Now let's try to write down the formula for Coulomb's law. The formula for Coulomb's law is this, that is F is equal to KQ1 Q2 over arrow square. Please take note. Now this arrow can either act as distance, can also act as radius. Now it can act as radius if the question is on atom, but if the question is not related to atoms, the arrow here is acting as distance. Please take note of this, okay? So this K here is a constant, and the value for this K is 9 times 10 to the power of 9. The unit is Newton meter square per coulomb square. Please don't forget. Why this Q1 is the first charge, while this Q2 here represents the second charge. Please take note. This force here can either be force of attraction or force of repulsion. Okay, now let's try to apply this formula here in the equation given to us. They said 2-point charges plus Q. We are taking one of it as plus Q, the other as minus Q, separated by a distance D. Okay, so applying this here using the Coulomb's law, our F will be equal to class. F will be equal to, we are taking K, we are taking Q1 as plus Q, small letter Q, and we are taking the second charge as minus Q. Please take note. Over the distance at this point here is D square. We are replacing the arrow as D square, the value will be D square. So the value here will be equal to, if we multiply, this will be minus K, small letter Q, capital Q over D square. We'll call this equation 1. Please take note. So let's move over to the next statement. From the next statement here, from the next statement, they said if the charges on both particles are doubled, so we have to restructure the diagram again. So we have this to be, we have to restructure the diagram here. We have this to be plus q, and we have this to be minus q, separated by the same distance here, which is d. So it's being doubled. So I will double this 2. I will double this here 2. So 2 times plus q will give us plus 2q. 2 times minus q will give us minus 2q. Calculator q, okay? So let's find the force between them. Remember, to find the force between two charges, we apply Coulomb's law. So I will have this to be F to be equal to, this will be K. Q1 is this one here, the first charge, which will be plus, that is plus 2q. Q2 will take the place of minus 2 capital Q, that is minus 2 capital letter Q over d square. So let's simplify this. This will be equal to K, F, sorry, F is equal to minus 4, um, minus 4K, small letter Q, capital letter Q over d square. This is my equation 2. So this first statement gave us equation 1. The first statement gave us equation 1. The second statement gave us equation 2. But we are not asked to find two forces. We are asked to find a single force from this option there. Okay. Now let's combine the first one, the equation 1 and equation 2 together. Let's combine equation 1 and equation 2 to get a single force. We substitute equation 1 into equation 2. Let's write down the equation 1. Equation 1 is equal to F. Equation 1 is F equal to minus K, small letter q, capital letter Q over d square. This is our equation 1. Equation 2 is F is equal to minus 4K, small letter q, capital letter Q over d square. This is equation 2. Okay, now we have to substitute equation 1 into equation 2. We have to substitute equation 1 into equation 2. And if you look into equation 2 here, we are having a equation 1 into, we are having equation 1 in equation 2. If you write equation 2 in this way, we have something like this. F is equal to, if I to add the number, we have this to be minus K, small letter q, capital letter Q over d square. When you factor out the number, that is 4, we have 4 into minus kq, capital letter Q over d square. This expression here replace equation 1. So it means that anywhere we see minus k, small letter q, capital letter Q over d square, we replace that as this here, F, which is this here. Okay. So when you do that, we have something like this. F is equal to 4F. This is our answer here. When you do that, we have this to be F is equal to 4F. All right, let's solve the next question here. If you have any question on this particular question, solution here, you can ask it on the comment section. Okay, let's solve the next question, question 3. Let's solve this question here. They said an electric kettle draws a current of 4.0 amp when operated by a 230-volt source. Calculate the power rating of the kettle. The options are given to us here. Let's calculate the electric power here, but before we calculate the electric power, let's write down the given parameters. Solution first. All right, the given parameters here are current, which is given to us as 4.0 amp. The potential difference volt is given to us as 230 volts, and the next one given to us here is the next parameter here is power, which we are asked to calculate. All right, so before we calculate power here, let's know the analogy of power in mechanics and electricity. That is the relationship between power in mechanics and also power in electricity. Okay, we said that power in mechanics is equal to work done over time taken. Now, from the definition of work done in mechanics, where work done in mechanics is force times distance. All right. Now we have to relate this particular formula here to electricity. In electricity, force is equivalent to voltage, distance is equivalent to charge, velocity is or speed is equivalent to current. Okay, so we have something like this from our analogy. This is mechanics here. This is electricity. The first relationship here is force is related to voltage in electricity. The second here is distance or displacement, which is related to charge. The next is velocity or speed, which is related to current. Please take note. So from our analogy here, you can easily relate the work done as electrical work done, okay? But before then, let's write down this in the power. Power can be given as work done over time, which work done from mechanics is force times distance over time. So let's relate everything here to electricity. Force is voltage, distance is charge over t. Time remains the same both in mechanics and electricity. Now from the definition here, the only thing that defines a quantity here is charge over time taken, and charge over time taken define charge over time taken defined current. Okay, that is q over t defined current. Okay, now at this point here we have this to be p is equal to v times I, which is the same thing as IV. Okay, so this is the formula for current. This is the formula for electrical power. Please take note of that, related to current and voltage. Okay, we also have other formula, but this is a fundamental formula. Okay, now any other formula depends on Ohm's law, where you can use Ohm's law to calculate the missing parameter here. Okay, so if voltage is not given, you can use your Ohm's law to calculate voltage, then replace voltage here. If current is not given, you can use your Ohm's law to calculate current and then replace current here. Okay, so let's solve this question here. To calculate electrical power here, P will be equal to current is given to us. Current is given to us as 4, while voltage, that is the potential difference, is given to us 230 times 4, On the punch your calculator, we have this to be 920 watts. The unit of power is either in kilowatts or in watts. Okay, so let's solve the next question here, question 4.